So for the next 2 hours or so, we'll go over pretty much the basics of two-way post-tension slab design. If this is a topic that you're interested in, hopefully you are because you're here or you just have trouble sleeping, you can purchase my book, and my business partner is the co-author, Mr. Dirk Bondi. This book is in its 4th edition. It's basically everything that we do here at Seneca in terms of post-tension concrete. So if it's the first half of the class, or excuse me, the first half of the book, so the first 10 chapters, I believe, is the undergraduate class that the book is used at several universities to teach. So if you basically are starting from ground zero, which is great, this would be a good thing to pick up. Also, the last half of the book is the real world, quote unquote, examples where we discuss how we use post-tensioning in the quote unquote real world, garages, podiums, hotels, stuff like that, what we deal with on a daily basis. There's a lot of pictures besides just the numerics, so if any of this sounds interesting, please pick it up wherever you shop for books on technical natures. So two-way slabs, just a real quick overview. They are used in all types of building applications, parking structures, hotels, office buildings, apartments. It's pretty much the most useful framing system we have. From a very generic standpoint, the columns are typically in a rectangular pattern. The most efficient would be a square 1-to-1, but typically up to 1-to-1 to 2-to-1 can be used with a two-way system and maintain some level of efficiency. Obviously, we rarely get a 1-to-1 ratio, but if you have, let's say, 15 feet one direction, 45 feet in the other, the 45 feet is going to govern, so a two-way slab would not obviously probably be the most efficient system because of the long direction governing the design. The main issue is they are supported by columns, isolated columns or wall piers. You typically don't have continuous supports, i.e. a very, very long wall or a whole series of beams. The slab is designed to resist load in both directions, so ergo a two-way slab. The major difference between a one-way slab design and a two-way slab is one-way obviously is only designed in a one-way dimension or a one-way direction. The other direction, because of its length and the thickness is based upon the smaller dimension, is just temperature and shrinkage reinforcement in the quote-unquote weak direction of the slab. So effectively, instead of designing beams and slabs, we design slabs in two different directions. So the same number of analyses for the most part, it's just instead of having a slab and a beam, you have two different slab designs. Because of the size of the columns, and unless you're dealing with extremely large columns, if you have a 80-story building or something, this may be a little different, but if you're doing a 5 or 6 story, whatever it is, the columns are typically designed for axial load. The columns are relatively small, so they can't develop the crank that a 24, 36-inch square column would do it. There is some moment transfer, but typically it's more of an axial load design than the moment. The shear design is controlled by punching shear. Obviously, one-way and beam shear don't apply to a two-way system, but punching shear is, if there's any Achilles heel to a two-way system, it is the punching shear. The biggest problems I've seen with two-way slabs are not fluxural resistance. It's usually either deflections or in a catastrophic event or a strength issue, it's punching shear. So, shear controlled by punching is probably the more critical item in terms of life safety, because if it's a brittle failure, there's minimal ductility, and when it slides down the column, there's not much you can do about it. In general, again, this is not a post-tensioning issue, but more of a two-way slab issue, whether it's a rebar-only slab or post-tensioning. They're typically best used for designing to resist uniform type loading, pounds per square foot, partitions, live load, stuff like that. If you're supporting large point loads, whether it's a tree, a discontinuous column, and stuff like that, and when I say large, plus 10,000 pounds, if it's 2,000 or 3,000 pounds, that's fine. But if you're supporting 20, 30, 40,000 pounds, that's challenging to resist in a two-way slab just because you don't have the depth, and it's hard to drape post-tensioning and get additional rebar for those localized effects. So if you have a whole series of large point loads, the two-way slab may not be the best choice for your system, or you may need to add localized beams for those conditions. Again, from a very generic standpoint, on the top of the slide, the one-way system has a beam on the bottom and a bearing wall on top, so the slab is only going up and down the page. The major difference on the second slide, or on the one on the bottom, is that the wall and beam have been replaced by columns such that they have to span in both directions to get the load from the center of the building. You go up or down the page, and then you go left or right in the design to carry it to the supports. The major difference is you have columns rather than beam and wall systems. So two-way flat plates. In general terms, the slabs are relatively thin. Typically, for most applications, you're looking at 7 to 12 inches. Hotels, parking structures, office buildings, stuff like that. Provided you don't have monstrous column spans, you're in the 8 to 9 inch range. Typically, the thicker decks in the 12-inch, 14-inch range would be your podium slabs, holding up landscaping, maybe fire truck loading, retail, stuff like that. But you're usually in the 8 to 10-inch range for most applications. Obviously, the slab thickness is based upon the largest interior span. Balance loads, which I'll cover a little bit later on, are still extremely critical. Basically, whatever you're designing in post-tensioning, the first thing I think you should check is balance loads before stresses, before ultimate strength. So slabs, one-way slabs, beams, girders, two-way slabs, mat foundations, whatever you're doing, you check balance loads first and then proceed with the other checks.